Okay, good afternoon, all. I welcome you all for this today's session. Okay, in this today's session, we are going to discuss the concept of powder metallurgy. Along with the concept of powder metallurgy, in this we are going to discuss the different methods of powder production. With help of these methods, we can do the production or manufacturing of metal as well as non-metal powders. And after that, we are going to discuss the various steps involved in the manufacturing of a component using powder metallurgy technique. And in that, we are going to discuss these steps. The first steps is powder production, then mixing or blending, the third stage compacting, then sintering, then sizing or coining, and last is testing and inspection. These stages we are going to discuss one by one in brief, and at the end we are going to discuss the advantages of powder metallurgy technique over our conventional manufacturing processes, then some disadvantages of powder metallurgy technique, and at the end we will discuss in brief the applications of this powder metallurgy technique and the components manufactured from this powder metallurgy technique. Yeah, one by one in this today's session only, we are going to discuss this. So we will start with the first point, that is, what is the meaning of powder metallurgy? What is the meaning of powder metallurgy? Okay, so powder metallurgy, it is a branch of metallurgy, you can say that, and it deals with the production of powders. Now in this, the production of metal powders, as well as we are manufacturing non-metals powders. Okay, we can manufacture metal powder and non-metal powders, and subsequently with help of these manufactured metal and non-metal powders, we can manufacture a component. Okay, this technique or this total science will be termed as a, or it will be considered as a powder metallurgy. Okay, I will repeat it again. The branch of metallurgy which deals with production of metal and non-metal powders and subsequently manufacturing of components using these powders will be termed as powder metallurgy. Now uh, from this metal or non-metal powders, we can manufacture a component. And how it is manufactured? The powder metallurgy components are manufactured by following certain stages. Initially, the mixing of metal or metal and non-metal powder is done, then compacting, which will be followed by simultaneous heating at high temperatures in controlled atmosphere, and at the end we will get the components having satisfactory or necessary strength and density. So this is the powder metallurgy technique. Okay, initially it will be divided in two parts, this powder metallurgy. First is the production of the powders, and in this we can manufacture metal powders as well as non-metal powders. And its second part will be manufacturing the component with the help of these powders. We can take any composition, we can manufacture a component with metal and metal composition, or we can manufacture a component with some metal and non-metal compositions also. And here, to manufacture this, certain stages are followed in some controlled atmosphere, and at the end we will get the final product by this powder metallurgy technique, which will provide you the necessary strength and density. Okay, now the generally in manufacturing a component from this powder metallurgy, uh, with the help of this powder metallurgy technique, general steps, there are 6 general steps involved in manufacturing of any component. These are the steps in manufacturing of a component using powder metallurgy technique. Okay, and generally 6 stages are there. In some specific cases, this number may be more or less, okay, depending on some operations may get added or some operations may get eliminated, but generally 6 stages are there. The first stage in manufacturing any component using powder metallurgy technique, the first stage is powder production or powder manufacturing. This is the first stage, and in this different stages are there. We will discuss it in brief one by one. And second stage is blending or mixing. Whichever powders we have selected, from that we are going to obtain the homogeneous mixture by performing blending or mixing operation. Then what is the difference between blending and mixing, that we are going to discuss in this session only. Then the third step is compacting or pressing. And fourth step is sintering. Fifth step is sizing or machining, or in some books it is mentioned as coining also. And the sixth and final stage will be testing and inspection. Okay, these are the 6 stages. Here I have highlighted in this diagram also steps involved in the manufacturing of a component using powder metallurgy technique. Metal powders are manufactured, and this is the first stage. Mixing is done with metal powders and some additives are required. And in the next stage, compacting is done. This is termed as compaction. Then sintering, then machining operations I have highlighted here. Some secondary machining operations or sizing operations, and at the end we will get the finished product. And on this we have to, before practically using it, we have to perform some testing and inspection. Okay, so these are the steps involved in the manufacturing of a component using powder metallurgy technique. Now one by one in brief, I am going to discuss all these methods. Okay, methods of powder production, then blending, mixing, how it is conducted, and how the compacting is done, how sintering is performed, how sizing or machining is done, how we are going to conduct the testing and inspection. One by one I will discuss it in the brief, the remaining session. Now again, this one more slide I have added. This will again highlight the same powder steps in the manufacturing component using powder metallurgy technique. We are taking these metal powders. Here I have mentioned the names of different techniques used for manufacturing the powder. Then its mixing or blending is done. Then compacting operation, different depending on our need, we can use different types of compacting operations. Then sintering and final finishing operation will be done, and then it is given to the testing and for testing and inspection before its actual use. In this simple chart also I have added here powder production. Then sometimes we require this powder characterization and testing, then mixing, blending, then compacting, sintering, and some finishing operations, and we will get the final product. These are steps involved in manufacturing the component. Okay, now the first step involved is powder production. Okay, this is the first step involved in the powder metallurgy technique is powder production. Now the powder production or powder manufacturing can be done in different ways. Okay, various methods are there, and each method will give you the different particle size, and the properties of that particular powder will be different. Okay, now how to choose the suitable method? Depending on the properties needed in the final product. Okay, depending on our need or desired properties in the final product, the suitable method we have to select from the available methods. Generally we have four methods of powder production or powder manufacturing in this powder metallurgy. Okay, I have highlighted here, or if it is not visible, I will show you that in the big slide. Okay, now it is visible. Okay, these are the methods of powder production or powder manufacturing. This is the first step, that is the powder production. Okay, now the powder production or a powder manufacturing can be done in different ways, and these are categorized in 4 methods depending on the technique used. It is characterized or classified in 4 different types. The first type is mechanical processes, second type physical processes, third type chemical processes, and fourth type electrochemical processes. Okay, now the mechanical processes are classified or it has 6 different methods like machining, crushing, crushing, milling, shooting, graining, and atomization. Okay, atomization. Then physical processes, like two physical processes are there, or physical processes are classified in two subtypes: condensation and thermal decomposition. And chemical processes are classified in three different types depending on the method used, as the reduction processes, then intergranular corrosion process, and precipitation from aqueous solution. And in this electrochemical process, only one method is there, that is electrodeposition. Now, one by one, we are going to discuss it. If it is not visible on your screen properly, you can zoom it. Okay, please zoom it to see it, the name carefully. Now, each method will give you the powder particles having different shape, size, and different powder characteristics. Then, depending on the properties required in the final product, we have to select the suitable method. Okay, now one by one, we are going to discuss each type and the powder characteristics of each type, shape, size, and its characteristic in each type. Now, the first, I will start with this mechanical processes. Six types of mechanical processes can be used in this powder production. The first method is machining. Okay, machining is the first mechanical process. Now, in this machining, what we are going to do, suppose we want to manufacture any metal powder. Okay, then what we are going to do, then its raw material is collected in the form of some rod, or in the form of some bar or plate, and it is collected, and a simple machining operation is conducted on it. And the powders, initially powders are obtained in the form of filings, chips, or turnings. Okay, after conducting the machining operation, that material will get removed in the smaller form, in the form of filings or turnings or chips. Okay, in this way the powder particles are obtained, but we cannot use these powder particles directly in our operation or for manufacturing the component. Then whichever the powder particles are obtained in the form of these chips or filings or turnings, we are going to perform for the second and third operation on it. It may be crushing operation, or it may be milling operation, to reduce its size or to make it suitable for our use. So in this way the machining process is conducted. Okay, in short, simply we are going to perform the machining operation on the raw material, and we will get the initially powder particles are obtained in the form of chips, filings, or turnings. Then we are going to make it suitable for our use by conducting the further mechanical processes like crushing or milling, and then we can use it for our operation. With the help of this machining process, the magnesium powder, we can manufacture the magnesium powder with help of, I will tell you one example, that is the magnesium powder can be manufactured with the help of this machining, and it can be used in different the alloys. Okay, like suppose it can be used in different pyrotechnic applications, or different, it can be used as in the silver soldering also. Okay, so this is the example. And this machining, the powder particle shape is irregular shape. Okay, we cannot get the definite shape here, as we are performing the operation by machining operation. The chips or turnings will be formed, and further they are subjected to crushing or milling. Now, how this crushing and milling is conducted, that I will explain here now. The second method of powder production in mechanical processes is crushing. Now, with how the powder is obtained in this crushing, the metal whose powder we want to manufacture is its raw material is taken, and that raw material is simply crushed with the help of some hammers or some crushers. These crushers may be jaw crushers or gyrating crushers. Simply you have to remember that it is crushed with the help of hammers or crushers. Simply raw material is crushed, and some it is transferred to the powder shape. Okay, now during this crushing, what will be the shape of the powder particles? Now, if you have obtained the powder particles with the help of this crushing, then depending on the material, type of the material, we will get the different shapes. Here, type of the material means whether that material is a brittle material or a ductile material. If suppose the brittle material is there, and after doing the crushing operation on that brittle material, whichever powder is produced, its shape will be angular. Okay, in some angle shape like this. Okay, different angle shape powders are produced by the crushing. Means this crushing can be done on brittle material as well as ductile material. When crushing of brittle material is done, the powder particles obtained will show you angular shape. Okay, and when we have obtained the powders from the ductile material, then its shape will be like flex shape. Okay, flex shape, like your pencil or pen, like that, smaller piece of pens like this, it will be flex shape. Okay, or we have seen that in the microstructure of gray cast iron, dark flakes of that graphite will be observed like that. Flakes will be formed, flake shape powder particles will be obtained after performing the crushing operation on ductile material. And here we are getting shape and size of the powder particles depending on the material type. If it is brittle, we will get angular shape. If it is ductile, we will get the flex shape powder particles. And this crushing technique is mostly suitable for brittle materials. Okay, it can be easily, brittle material can be easily crushed, and we can obtain the powder particles. The third step or third type, sorry, it is third type of mechanical processes to get the desired powder is the milling process. Okay, now in this milling process, what we are going to do in this milling process, we are simply taking one drum. Okay, one drum or container will be there, and in that some hard materials will be taken in the form of rod or disc, along with the raw material whose powder we want to manufacture. Okay, I will repeat it again. In this milling process, what we are going to do, one steel container will be taken, steel container or one drum, and in that drum we are going to take one hard material in the form of disc or rod or in this ball shape, that will be termed as mill rods or mill balls or mill disc. And in same drum we are taking the raw material. uh, from that raw material we are going to obtain the powder particles. And after taking this, that drum or container is rotated. Okay, with a little bit higher speed we are going to rotate it. And after rotating, okay, when we start the rotation, then inside that drum or container, okay, we are discussing this filling inside that drum or container, we have the raw material whose powder we want to manufacture, and some hard material in the form of rods or discs. Okay, now here in that disc or that rod, hard disc material or hard rod material, and the raw material whose powder we want to manufacture, the collision will occur during the rotation of that drum. In between that two materials, collision will occur, and the as the discs which we are using are very hard in shape, they will remove the material uh, from that plate of we are terming it as a raw material. The material will get removed in the form of some powders, and it can be collected at the end from that drum. So this is the milling process. In this way we can manufacture the powder with the help of this milling process. Now this milling process can be conducted in two ways. The first way is the dry milling process, and second way is the wet milling process. Now whichever process I have explained, the rotating drum then hard material in the form of discs or rods, and the raw material from which we are going to obtain the powder, and we are rotating it, and due to collision powder is collected in the drum and it is removed from the drum. This is dry method. And if the same method is conducted along with one liquid medium, adding one liquid medium inside that drum with the same raw material and same discs along with one liquid material, that liquid material may be distilled water or alcohol or acetone or stearic acid, then what will happen, the whichever rate of removal is there, material removal rate, it will increase, and this whole milling process will be completed with lesser time. And this method is wet milling method, because it is we are conducting it in the liquid medium, using suitable liquid medium, so that we will end up with the lesser time. So in this way this milling method is done. Now I will comparison will be there. Now in this milling method, whichever shape and size of the powder particle is obtained, uh, here we are going to obtain irregular shaped powder particles. And in all these three methods, in machining, crushing or milling, all the powder particles manufactured here, there will be some stresses will be there inside that powder particles. So all the powder particles manufactured with these three processes, that is machining, crushing and milling, they require annealing heat treatment process. Okay, heated to the some higher temperature zone, and holding there for some period of time, and then cooling in the furnace itself. Very slow cooling is required, so that we can eliminate the internal stresses which are created due to the these mechanical processes. And this is used after the completion of this machining, crushing and milling on that powder. Okay, in almost in this machining and milling, powder shape will be irregular, and in this crushing, if material is brittle, angular shaped powder particles are obtained, and if material is ductile, flex shaped powder particles are obtained. Now in these three steps, first three stages, the production rate is very low. Okay, production rate is very less or low. Then in the remaining three methods, production rate is very high. Okay, this shooting, graining and atomization, the and this is atomization process. Okay, third one. Now the fourth mechanical process of manufacturing of the powder is the shooting. Okay, this shooting and graining, the working principle is same, just what is the difference? Use of the medium used is different. In shooting process and graining process, the working principle is same, just one working medium is different. Now I will explain the shooting method. Now in this shooting method, what we are going to do, the metal whose powder particles we want to manufacture, that metal is taken in molten form, and it is poured on a vibrating screen. Okay, molten form metal is taken and it is poured on the vibrating screen. That vibrating screen has some openings. Okay, it has some openings, and due to the vibration, that molten metal will come out. Okay, in the form of liquid droplets from that openings, and that liquid droplets are solidified by passing the some air or gas medium. Due to some air or gas medium, it solidifies and powder particles are obtained. Okay, this is the shooting method. Now in this shooting method, whichever powder shape of the powder particle is there, it depends on the temperature of molten metal. Okay, temperature of molten metal, and then opening size of that vibrating screen. Suppose this is the vibrating screen, then its opening size of this vibrating screen, and opening size and the speed of this vibration. You can say that frequency of that vibrating screen. Depending on this, we will get the shape of the powder particle. And generally in this shooting method, whichever powder particles are obtained, they are spherical in nature. Okay, spherical in nature. Okay, this is the concept of this shorting method. Then the graining. And the next method is graining. In this graining method, concept is same. The metal whose powder you want to manufacture, that metal is taken in the molten form, and that molten metal is poured on the vibrating screen. The molten metal is poured on the vibrating screen, and that vibrating screen has some openings, and due to the vibration of that vibrating screen, from that opening, that molten metal will come in the form of liquid droplets, and with the help of water medium, that liquid droplets are solidified and powder particles are obtained. Okay, this is the graining method. Now here also, the shape and size of that powder particle depends on three parameters. The first parameter is temperature of the molten metal, then the opening size of that vibrating screen, and frequency of that vibrating screen. Now here also, depending on the use of that opening size of that vibrating screen, we can get this spherical powder particles. Okay, in this shorting and graining method, we can grade the spherical powder powder particles with spherical shape. Okay, and then atomization is the next stage. This is atomization. Okay, atomization is the sixth stage, or sixth type of mechanical processes. For this atomization, I have added some diagram. This is atomization. Now atomization, here it consists of two chambers. This chamber, in the second chamber, some controlled environment or vacuum is there. Okay, and one cylindrical chamber is there, or box is there, having one opening at the bottom. Okay, this atomization technique has two types. Okay, atomization has two types depending on the medium used. Okay, it first I will explain the principle. In one tank having, or in one cylinder, or one container which has the opening at the bottom, the molten metal is taken. This is the molten metal. It has some opening at the bottom, and from that bottom opening, the liquid droplets will come out. Liquid droplets will come out of that molten metal, and these liquid droplets are solidified. Okay, solidified by using high pressure water jets, or it can be solidified by compressed air. If these powder particles are solidified with the help of high pressure water jets, then that atomization technique is termed as water atomization. And if these liquid droplets are solidified with the help of some gases like argon, nitrogen, or helium, this will be termed as gas atomization. Okay, the medium used to convert this liquid molten droplets into solid powder particles, depending on that, this atomization is classified in water atomization and gas atomization. Okay, so in this way, these two types are there, and using this atomization techniques, the powder particles are collected at the bottom of that chamber, and from that, one opening will be provided there, and through that opening, these powder particles can be obtained or collected or removed. This is atomization technique. Now in this atomization technique, we can use water atomization or gas atomization, and the whichever powder particles are obtained, it has spherical shape. Okay, spherical shaped powder particles are obtained here. So in this way, we have discussed this 6 mechanical processes of powder production or powder manufacturing: machining, crushing, milling, and last we are shorting, graining, and atomization. This is not atomization. Atomization is there. And in this last 3 techniques or 3 methods, Okay, shorting, graining, and atomization. These three techniques, the rate is very fast, production rate is very high. Production rate is very high, and in first three techniques, production rate is very low. These three techniques will provide you rapid production rate, and in these three techniques, we will get the spherical shaped powder particles. And one more care you have to take, these three techniques can be applied on the metals having lower melting points, lower or medium melting points. Okay, above 1500 we cannot use this shorting, graining, or atomization technique, because it is very difficult to melt the that metal, because we are using molten metal in this technique. Three techniques we are using molten metal. Hence, these can be used when a metal has low or medium melting point only. If melting point is above 1500 degrees Celsius, then we have to go for these remaining three methods, anyone from these remaining three methods, or other methods like physical, chemical processes can be used. Okay, this is the limitation of these three methods: shorting, graining, and atomization. What is the advantage? It will provide spherical shaped powder particles, and one more advantage is rate is very fast. Material removal rate or production rate is very high. Then after discussing this, if you have any doubt, you can mention that in the chat box. I will resolve it. And then the next type of powder production is physical processes. Now, in this physical processes, it is classified in two different types. The first is condensation, and the second is thermal decomposition. Okay. Now here condensation. Okay. Now here the condensation. This process is what we are going to do in this process. Uh, Suppose we want to manufacture some metal powder, then its metal vapors are taken, and that metal vapors are condensed to give the some spherical shaped powder particles. Okay, that metal vapors are condensed, and now this condensation method is useful only for that metals which are highly volatile. Okay, like magnesium or cadmium, these are highly volatile metals, so they can be easily converted into their metal vapors. So they are converted in metal vapors, and they are condensed using suitable medium, and we will get the spherical shaped powder here in condensation. Okay, cadmium, then magnesium powders can be manufactured. Magnesium powder can be manufactured with the help of this condensation process. Then the second physical process is thermal decomposition. Now here also what we are doing, again we are taking vapors of that respective metals, but in the form of their respective carbonyls. Okay, first that metal carbonyl vapors are formed, and that metal carbonyl vapors are decomposed to give the particular metal powder. So I will explain it with the help of some reactions. Okay, this is the thermal decomposition method. This is the second physical method of powder production. Okay, with the help of this, we can obtain the powder of different metals like iron, nickel, tungsten, molybdenum, cobalt, magnesium. Okay, all these fine metal powders can be manufactured by thermal decomposition of their respective metal carbonyl vapors. So what is the meaning of this metal carbonyl? Okay, metal carbonyl vapors, that metal carbonyl in the form of vapor. Now initially, suppose we want to here I have taken two examples: iron, manufacturing of iron powder, and manufacturing of nickel powder. Then suppose iron, initially consider only iron reaction. Okay, then iron carbonyls are produced. How the carbonyl compounds are formed? By passing carbon monoxide over the that iron metal at temperature 200 to 270 degrees Celsius temperature, and 70 to 200 atmospheric pressure. Okay, Then this iron, and due to this presence of carbon monoxide, it will form its respective carbonyl. Okay, this FeCO5 is iron carbonyl. Iron carbonyl. Now this iron carbonyl is volatile liquid. And now we are going to convert them into the vapor form, and they are decomposed at 1 atmospheric pressure and 150 to 400 degrees Celsius temperature. These are reaction conditions. And this iron carbonyl, it will decompose at 150 to 400 degrees Celsius temperature and 1 atmospheric pressure, and the iron particles are separated here. These iron particles, Fe powder particles, are separated, and this carbon monoxide will be again circulated, and then again it will combine with the iron to form its respective iron carbonyl or metal carbonyl, and again it decomposes at the given temperature conditions to form iron. Now, whichever iron powder particles are produced by this thermal decomposition method, these iron particles are spherical in nature. Here you can see I have highlighted here spherical in nature or spherical shape. Now, this same thermal decomposition reaction can be used for manufacturing of nickel powders. Okay, how it is done? Now, this nickel, okay, nickel metal. Here we are going to convert it into its nickel carbonyl by passing carbon monoxide over it. Okay, initially this nickel metal powder can be taken in the form of powders, which is manufactured by mechanical processes, and on that we are doing this further processing. Okay, this nickel metal powder will be there, then the carbon monoxide gas is passed, and it will get converted into nickel carbonyl. This is nickel carbonyl, NiCO4, nickel carbonyl. And this nickel carbonyl is highly volatile liquid. Then at 150 to 400 degrees Celsius temperature range and 1 atmospheric pressure, this nickel carbonyl decomposes. Okay, it breaks and it forms the nickel powder particles plus carbon monoxide gas is released, which is again recirculated for the same process. And this powder particles formed of this nickel element, this will be irregular in shape here. Okay, depending on the metal, different shapes will be obtained. Iron powder particles will get the spherical shape. Okay, different powder particles can be manufactured with this thermal decomposition: iron, nickel, tungsten, molybdenum, cobalt, magnesium. But this method is specifically or most commonly used for iron and nickel. Okay, to manufacture iron, spherical particles of iron and irregular shaped particles of nickel element. This thermal decomposition method is used. Okay, so after discussing this, we will move towards the next type of powder production or powder manufacturing: chemical processes. Now there are different chemical processes. Okay, three chemical processes are there. If you have any doubt, please ask me. Chemical processes, three chemical processes are there. Please let me know. Okay, now we will discuss one by one chemical processes. The first chemical process is a reduction. Okay, I will continue now. Okay, the first chemical process is a reduction. Now in this reduction technique, what we are going to do in this reduction technique? Okay, in this reduction technique, what we are going to do here in this reduction, so the metal whose powder we want to manufacture, its respective compounds will be taken in the form of some oxides or halides or formates or oxalates. These are different forms. Means that particular metal in the form of its compound is taken, and its reduction is done with the help of some reducing or suitable reducing agents. I will explain this one with one example. Suppose we want to manufacture tungsten powder, that is W. Then its respective compound, suppose oxide, tungsten oxide, WO3, tungsten oxide is taken, and it is reduced, means chemical reaction will be done in presence of carbon or hydrogen. Okay, then if in presence of carbon its reaction is done, then that carbon will combine with the oxygen and tungsten will get separated. That tungsten will be obtained in the form of some powders. Okay, in this way we can manufacture the tungsten powder, or in the same way tungsten powder can be manufactured with the help of tungsten oxide, that is WO2, and the reducing agent may be carbon or hydrogen. If tungsten is manufactured by using the carbon as a reducing agent, then that tungsten we are using for manufacturing of the uh, cutting tools. Okay, and if the tungsten is manufactured with the help of hydrogen, okay, hydrogen as a reducing agent, then that tungsten will be used in the filaments of our lamp, okay, or some electrical contact materials. Okay, then in the same way we can manufacture the molybdenum from its respective oxide, that is MoO2. We can use carbon or hydrogen as reducing agent, and in this that hydrogen will react with the oxygen. It will separate that oxygen or that carbon. If we use the carbon as reducing agent, that carbon will react with the oxygen and molybdenum powder particles are separated. Okay, this is the reduction method. Okay, you can use this reduction method. Okay, in the same way we can obtain chromium powder, or you can say that zirconium powder. Okay, chromium powder or zirconium powder can also be obtained with the help of this reduction. Chromium powder is obtained by a reduction of chromium oxide with the help of magnesium element, or zirconium can be obtained by reduction of zirconium oxide by adding magnesium element. Okay, in this way tungsten, molybdenum, chromium, zirconium, like these different powders can be manufactured by reduction of their respective compounds by using suitable reducing agent like carbon, hydrogen, or some other elements. Okay, this is the reduction method. In this reduction method, the whichever powder particles we are obtaining, it is irregular in shape. Okay, irregular shaped powder particles are obtained in this reduction method. So after discussing this reduction method, the next method is irregular, sorry, not irregular, it is intergranular corrosion. Okay, second type of chemical process from which we can manufacture different powders is intergranular corrosion. An example of this intergranular corrosion, we can manufacture stainless steel or steel powder. Generally it is used for stainless steel, and it is in the older days we are using these processes. Nowadays this is eliminated by atomization technique. Okay, intergranular corrosion. Now how we are using this intergranular corrosion principle? Okay, here you have to understand that whenever any material comes in contact with corrosive environment, okay, in the corrosive environment what will happen? Initially grain boundary of that particular material will suffer the corrosion, or it will get corroded, and after that grain boundary is corroded completely, then corrosion of grains start. Okay, this principle is used in this intergranular corrosion. How this is used? We are using some controlled corrosive environment, and using that controlled corrosive environment we are just corroding the grain boundaries, and grains are separated. For stainless steel, we are corroding its grain boundaries and stainless steel grains are separated. Suppose one material is there, okay, this is the grain boundary. Inside that grain is there, inside that, suppose inside that grain is there. So this is the material. Then when it comes in contact with the corrosive environment, its boundary will corrode first. Okay, and after that grains will corrode if more corrosion, if they come in contact with the corrosive environment. This principle is used. Now how the its example is stainless steel. Okay, nearly we are getting spherical stainless steel powders. Okay, spherical depending on the condition, but largely it is giving I think angular. Okay, sorry, in the intergranular corrosion, whichever stainless steel powder is manufactured, it is angular powder particles we will get. Now how this intergranular corrosion is done? Initially we will take this stainless steel. Okay, now this stainless steel, as the stainless steel, we know that the stainless steel is uh, alloy of iron and carbon, and in that the principal alloying element is chromium. Okay, chromium is there. And then we are going to heat it at some temperature range of 500 to 800 degrees Celsius. We are heating that stainless steel. Okay, and after continuous heating of that stainless steel at the temperature zone 500 to 800 degrees Celsius, then whichever chromium is present in that stainless steel, it combines with the carbon at higher temperatures and it forms chromium carbides, and that chromium carbide will accumulate the space near grain boundaries, and due to presence of that chromium carbide near grain boundaries, that stainless steel or that grain boundary region becomes more sensitive or more susceptible for corrosion. And after this process, we are heating the stainless steel in at that 500 to 800 degrees Celsius zone for very long period. Then this chromium carbides are formed and accumulated at grain boundaries. Now that region becomes very sensitive or susceptible for corrosion. Now we are taking that stainless steel from that high temperature zone, and now we are taking one aqueous solution of 11% CuSO4, that is copper sulfate, and H2SO4, that is sulfuric acid. 10% sulfuric acid, 11% copper sulfate we are taking. And in that aqueous solution, we are taking that stainless steel and we are boiling that aqueous solution. Okay, we are providing some smaller quantity of heat. Then what happens here? Due to that aqueous solution, grain boundaries which are more sensitive due to the accumulation of chromium carbide particles at the grain boundaries, it will get corroded, and after some time the grains will get removed. Okay, grains with some angular shape are obtained with the help of this intergranular corrosion. Okay, in this way stainless steel powder particles having angular shape is obtained with the help of this intergranular corrosion. Okay, angular shaped powder particles are obtained. Now the next stage is precipitation from aqueous solution. Third chemical process of a powder production is precipitation from aqueous solution. And now in this precipitation from aqueous solution, we are using one basic concept or basic principle, that if suppose there is an aqueous solution, and in that aqueous solution we are adding one metal which is less noble, that is having more valency. Okay, more valency or more electron accepting capacity, then it will separate the more noble metal from that aqueous solution. Okay, and this is related to the chemistry, one concept is there, and depending on this concept, this precipitation from aqueous solution, we are obtaining the powder particles. Suppose CuSO4. Okay, CuSO4 aqueous solution is there, and if you are adding iron in that, if you add iron in that, then that iron will displace that copper, and that it will form FeSO4 or its respective compounds, and that copper particles will be separated. Okay, copper particles will be separated. Suppose we want to manufacture some, suppose silver nitrate is there, sorry, means we want to manufacture silver powder. Then in that silver nitrate we are going to add copper or iron. Okay, that copper iron will displace that silver from that aqueous solution. Then suppose we want to manufacture tin powder. Okay, we want to manufacture tin, that is SN powder. Then we are going to add zinc in its compound like stannous chloride. We are going to add zinc, then it will display the tin. Means with the help of this precipitation from aqueous solution, different powders of copper powder, silver powder, uh, or tin powder can be obtained from its respective aqueous solution by adding less noble metal in it. Okay, and the shape obtained here with the help of this precipitation from aqueous solution, shape of that powder particle is dendritic shape. Okay, dendritic shape means tree-like structure. Tree-like structure. One stem will be there and some branches will be there. That is the dendritic shape. Already we have discussed this dendritic shape. Powder particles are obtained, and very high purity will be there in this precipitation from aqueous solution. So these are some processes, chemical processes. Then the next method is electrochemical process. In this, electro deposition method is there. Now how these powder particles are obtained here? Now in this electrochemical process, or here electro deposition is there. What we are doing, some arrangement is there, cathode anode arrangement is there, and aqueous solution is there, and we are passing some current through it. Okay, high density current is passed. Then from that aqueous solution, on the cathode, respective powder particles are collected. Okay, this is the concept used in this electrochemical process. Okay, or electro deposition, it is also known as electro deposition. Now this electro deposition is obtained in three ways. Okay, on the cathode, the powder particles, hard and brittle powder particles are obtained, and they are separated by grinding operation, and powder is obtained. This is the first way. In the second way, on the cathode, we will obtain a spongy, soft and spongy mass of that powder particles, and simply by rubbing operation, that from that cathode we will be able to separate the powder particles. This is the second way. And third way, whichever powder particles are separated, that will accumulated at the bottom of that aqueous solution mixture in that container, or that whichever cylinder we are using or equipment we are using. In that, we will get the powder at the bottom. Okay, in these three ways we will get the powder, and approximately whichever powder particle we are adding here in this electrode deposition method. Now this electrode deposition, you can say that it is very much similar to the electroplating concept. Electroplating concept, if we have discussed that, it is very much similar process. Now here in this shape of the powder particle is dendritic shaped powder particle is obtained here. Okay, in the this aqueous solution, where we are using the aqueous solution, here also aqueous solution, here also aqueous solution. In this both methods, that is precipitation from aqueous solution, and in electrochemical process, that is electro deposition, here also the shape of the powder particle is dendritic, that is tree shape, and purity will be very high in these two processes. Okay, in this way, these are the different methods of powder production or powder manufacturing which we are using in the powder metallurgy. uh, okay, and a suitable method is selected. This is the first step, that is the powder production. Powder production is the first step in the manufacturing of any component using powder metallurgy technique. Okay, this is the first step, and we have to select the suitable method from these available methods depending on the desired properties in the final product, shape and size of the particles. You have to identify required shape and size of the powder particle, and suitable method you have to select. Okay, now after discussing these different methods of powder production, this is the first step. Now we will move toward the second step in this manufacturing a component with the help of powder metallurgy technique. Okay, this is the first stage. I have explained it in brief. Powder production, and depending on the final properties required in the final component, suitable method is selected. Okay, depending on suitable method of production of powders is selected from these types which I have shown here. This is the first step. After selecting suitable powders in the first stage, second stage is mixing or blending. Okay, mixing or blending is done. Now during this mixing or blending, what we are going to do, whichever metals powders or metal and non-metal powders we are using, the uniform and homogeneous mixture is obtained during this mixing or blending process. Okay, uniform and homogeneous mixture is obtained. Now to obtain or to do this mixing or blending operation, we can use different okay. Now okay, this is the second step in the powder metallurgy technique, mixing or blending. This mixing or blending is done to obtain the uniform and homogeneous mixture of whichever metal powders we are using or metal and non-metal powders we are using. Now this mixing or blending can be done using the different blending or mixing devices like rotating drum, then rotating double cone blender or Y cone blender, then screw mixer, blade mixer. With the help of these different devices, this blending or mixing can be done. Then what is the difference between the blending and mixing operation? Okay, from word you will find that it is similar, but there is small difference. When we are mixing powders of same chemical composition but different sizes, okay, when we are doing the mixing of powders with same chemical composition but different particle sizes, then it is termed as a blending process. Okay, it is termed as blending process. And when we are combining the powders with different chemistries, means different chemical compositions, and powder size may be same or different, then it will be termed as mixing. Okay, different chemical compositions or different chemistries, when we are combining that powders, it will be termed as mixing. Okay, and then this mixing or blending can be done with different blenders or mixers available. So here this is the rotating drum. This is a rotating drum. Around with the help of this shaft, we can rotate this drum. Inside this, we are going to take that powders as per our requirement. We are going to choose their quantity and composition. We will decide, and it is mixed in this drum, rotating drum. And this is a rotating double cone blender. Okay, double cone blender. Okay, with the help of this shaft, this double cone blender is rotated. And this is the screw mixer. It has screw type structure which is rotated, and inside this drum we are taking that metal powders or metal plus non-metal powders, and this screw is rotated with high speed to get uniform and homogeneous mixture. And this is a blade mixer. Okay, blade type structure is there. With the help of these different devices, blending or mixing of the powders can be done. Now during this blending or mixing, depending on our requirement, some other elements like lubricants, binders are added. Okay, okay, lubricants are added. Why lubricants are added in the mixing or blending stage? Because in the next stage, that is in the compacting stage, we are going to do the compacting or pressing operation, and there will be some friction between wall of the die cavities and the punch or plunger. To reduce that friction, we are adding lubricants. Then some binders are added during the next stage, that is compacting or pressing. binders are added to so that bond will get easily created between the different powder particles. That's why we are adding the binders. Okay, and when bond is created, we will get the enough strength before that sintering stage. Then defloculants are added to improve the flow characteristics during the feeding stage of compacting. Okay, feeding stage of compacting to improve the flow characteristics of the powder particles. Defloculants are added. Okay, now whichever lubricants or these defloculants are we have added, they plays their role, and these lubricants, okay, they are having role in only compacting process. Hence, before starting of the sintering stage, okay, before starting of the sintering stage, these lubricants are removed by conducting some preheating or pre-sintering operation. Okay, heating the component at some 400 to 800 degrees Celsius zone. Whichever lubricants we have added, that lubricants are uh, removed. Lubricants like graphite we are adding, graphite or silica, these are we are using as a lubricant, and that graphite particles or silica particles are removed before start of that sintering stage, because that lubricant, if they get carried in the final product, and then it will reduce the mechanical properties like its strength will get reduced at the final stage. Okay, hence these lubricants which we are adding in the mixing or blending stage are removed before sintering operation. Okay, so this is the second stage, mixing or blending, and it is done to obtain homogeneous and uniform mixture of metal powders or metal and non-metal powders with the help of suitable devices. It is done like devices like rotating drum, then double Y cone blender. This is double cone blender. Okay, double cone, then screw mixer or blade mixer. Suitable blending and mixing devices are used to obtain this uniform and homogeneous mixture of powders. And we are adding required lubricants, binders, and defloculants to get the desired properties as per our need. And then the third stage in this powder metallurgy technique is compacting or pressing. Now, this compacting or pressing, I will explain it. It consists or it is done in three stages. This compacting or pressing is done in three stages. That is filling, pressing, and ejection. Okay, filling, pressing, and ejection. Whichever part I have added here, that I will explain with the help of a diagram. Okay, here you can see this is the diagram from book. This is the filling operation, pressing operation, and ejection operation. Okay, now after performing the mixing or blending, we will end up with the uniform and homogeneous mixture, and there we have added some lubricants or binders in that as per our need. Then with the help of hopper or feed shoe, this is hopper or feed shoe, with the help of this hopper or feed shoe, the powder particles are poured or filled in the metal die cavity. Okay, this is a metal die cavity, and in this metal die cavity, we have along with that two punches or plungers, lower plunger and upper plunger, and this is a die cavity. And in this, we are feeding that water with the help of one feed shoe, and the volume of this metal powder or this mixture can be volume can be adjusted with the help of this lower plunger by raising or lowering the by raising it or lowering it. We can adjust the volume of the powders, mixed powders. Then after filling it completely with the help of a one sweep, with the one sweep we have to level it. One sweep of this feed shoe or hopper, this it is leveled. So this is the filling stage. Okay, uniform and homogeneous mixture obtained after blending or mixing. It is filled in the metal die cavity with the help of a feed shower hopper, and volume is adjusted with the help of this lower plunger. This is the filling stage. Then the next stage is the pressing stage. Pressing stage. In this pressing stage, what we are doing, whichever powder is filled here, now with the help of any one punch, either with the help of upper plunger or lower plunger, we are going to apply the pressure. We are going to apply the pressure. Now, you can use the upper plunger for the application of pressure, or simultaneously upper plunger and lower plunger can be used to do the pressing operation. In this way, sufficient pressing is done in this stage. We have to avoid very low pressures as well as very high pressures. If we are using very low pressures, whichever powder we are getting the component, the powder particles will be remain loosely attached, or that component will become fragile. And after completion of this process, powder particles may get removed automatically, detached from this component. So that we have to avoid low pressures, and as well as we have to avoid higher pressures also. If high pressures are there, it may damage these punches or plungers, or it may damage these die cavity walls. Okay, so proper values of the pressures should be selected. Generally we are using 1 to 150 kg per mm square pressure values in this pressing method. Then after sufficient pressing, okay, after sufficient pressing, that component is ejected from that metal die cavity with the by raising the lower plunger, and the component obtained at the end of this compacting stage, this component here, it is termed as compact, or it is also termed as green compact, because it has improved density. Improved density is obtained, hence it is also termed as green compact. Now, during this compacting stage, what changes are occurring in this metal powders? Initially, in this metal powders, here you can see more voids are present. Okay, more voids. Due to this pressing, voids are eliminated. Voids are, we have eliminated that voids. Due to that, density has increased. Okay, voids are eliminated, due to that porosity is decreased, and it results in increase in the density of the component. Then the next advantage what we have got in this is due to the continuous pressing. Due to continuous pressing, what happened here, in that whichever powder particles are there, they will get some adhesion to each other. Means adhesion or some cold welding will occur. Means powder particles will get joined to each other. Okay, this is one powder particle, this is another powder particle, they will get joined. Adhesion or cold welding will occur. Due to this, strength of that particular component is increased. Okay, strength is increased. Okay, in the first stage, voids and porosity is decreased. Due to that, density will get improved. And the second effect of this compacting is, what will happen in the powder particles, some adhesion or cold welding is occurring. Due to that, strength is increased. And in the third effect of this, there is some plastic deformation between the powder particles due to that pressing. It will also result in the improved strength. And the fourth effect is, due to this plastic deformation due to the pressing, it will help in the next stage, that is the sintering. Okay, so these are the four effects of this compacting, and they will give you help in the next stages. Okay, now this compacting method can be classified in two different ways. Okay, in this way compacting is done: filling, pressing, and ejection of the component. Component obtained at the end of this compacting is termed as green compact, simply compact or green compact. Why it is termed as green compact? It has improved density, that's why it is termed as green compact. And strength is also improved. These are stages I have highlighted in this slide also. Filling, okay, this is die cavity, lower punch, upper punch, and the filling, metal powder filling, then compaction or pressing, and this is the ejection of that part. These three stages are there. I have highlighted in this slide also. Then there are two types of this compacting. Okay, during the pressing, depending on by which way we have done the pressing or compaction, two types are there of this compacting, that is hot compacting and cold compacting. If during the pressing or compaction we have only used pressure with the help of upper punch or lower punch or both, then it is termed as cold compacting. It is termed as cold compacting. And if during the compaction or during the compacting we have used pressure with the help of upper punch, lower punch, or both punches, and simultaneously we have provided some amount of heat also, then that type of compacting is termed as hot compacting. Okay, it is termed as hot compacting. In cold compacting, only pressure is used for compaction, and in hot compacting, pressure and heat simultaneously used for compaction. So these are two types of compacting: cold compacting and hot compacting. And depending on the mediums used in that cold compacting has several types. That is isostatic pressing. If gaseous medium is used for the compaction, it is termed as isostatic pressing. If hydraulic medium is used for pressing, then that cold compacting is termed as hydrostatic pressing. If some explosion is used for doing that compacting, it is termed as explosive forming. If compressed gas is used, then it is termed as high energy rate forming. Then powder rolling, powder extrusion, or vibratory compacting, different methods are there. These are examples of cold compacting. Then there is compacting methods where we are using pressure as well as heat simultaneously, and these are termed as hot compacting methods. For example, hot extrusion, hot rolling, hot isostatic compacting, then hot coining, then powder forging. These are methods of hot compacting. Okay, and so depending on our need, we can go for cold compacting or hot compacting. Okay, so this is the compacting or pressing. All these points I have explained with the help of that diagram. Please try to understand the diagram. Okay, these are the stages. Then here the density of this compact or green compact depends on the compacting pressure. Okay, here it will, this graph will explain you the effect of compacting pressure on the density of the component or density of the compact. As gradually we are increasing the compacting pressure, the density of the compact or density of the green compact or the component obtained at the end of the compacting stage, it gradually increases. Okay, this is the effect of compacting pressure on the density. Then the next stage in this powder metallurgy technique is sintering. If you have any doubt, you can ask me via chat box. Okay. Okay, sintering is the next stage. In this sintering stage, whichever compact or green compact is obtained at the end of compacting stage, now this sintering stage, we are going to heat that green compact at a particular temperature range, with or without pressure, for 30 minutes to 2 hours, depending on the shape and size of that component. Okay, it is heated in the controlled environmental conditions with or without pressure for 30 minutes to 2 hours to improve its or to increase its strength and hardness. To increase its strength and hardness, this sintering is done. Now, what exactly happens during this sintering? When you start the sintering means that green compact is heated at high temperature range, and when you start this heating, then what will happen? Now this heating zone is selected in such a way that if suppose there is mixture of different metals, then the heating zone is selected in such a way that one metal will start the, means at least its melting will take place or deformation can start. In this way we have to select the sintering temperature. Now during this sintering, or this sintering is completed in 3 stages. In the first stage, diffusion will occur. Okay, one metal, means there is a mixture of different metal powders or metal and non-metal powders. Then depending on the sintering we are doing, then the diffusion of one metal will occur, or metal particles diffusion on other metal powders will start. It will start diffusing on other metal particles. Okay, means either it starts deforming plastically or it melts and it gets diffused on the other metal powder particles. This is termed as diffusion. And due to this diffusion, what will happen? Porosity decreases and decrease in the compact size will occur, and this decrease in compact size will be termed as a densification. Okay, densification will take place. And as due to the diffusion and densification, formation of grains, new grains will start. That is, it will be termed as recrystallization. Means older grains will break at this recrystallization temperature, and due to diffusion of one metal particles on other metal powder particles, recrystallization and its grain growth will take place. This is the third stage, and this will give you the increase the strength and hardness of that compact. Okay, and we will get the sintered component at the completion of this sintering stage. Whichever component is obtained, it is termed as sintered component. Sintered component. Okay, now depending on the temperatures used in the sintering process, the sintering process is classified in two types. The first type is solid phase sintering, and second type is liquid phase sintering. Suppose the sintering is conducted above the recrystallization temperature and below the melting point of low melting metal from that mixture. Okay, above recrystallization temperature but below the melting point of low melting point metal from that mixture, then it is termed as solid phase sintering. And if the sintering is done above the melting point of one of the metal from that alloy constituent, okay, having low melting point above that melting point, then it will be termed as liquid phase sintering. Suppose two powder particles are there, A having 300 degrees Celsius melting point and B having 500 degrees Celsius melting point. If we are heating it above 300, means A will start melting, then it is liquid phase sintering. Okay, in solid phase sintering, no metal will melt here. Melting does not occur here. Only plastic deformation will occur because we are hitting above recrystallization temperature but below the melting point of low melting metal. Okay, low melting point metal. Okay, if suppose A and B metals are here also, A and B metals, if A metal is having 300 degrees Celsius melting point and B metal having 500 degrees Celsius melting point, then our recrystallization temperature is about 200 degrees Celsius or 150 degrees Celsius. Then only plastic deformation of metal A will occur. It does not melt. Okay, in this way these two sintering methods are there, solid phase sintering and liquid phase sintering. Now whichever sintering method we are going to use, these sintering processes are conducted in controlled environmental conditions. Means either we can go for a reducing atmosphere or neutral atmosphere or oxidizing atmosphere. Now this atmosphere is chosen depending on the metal powder types. Okay, whichever metal powder types we are using, depending on that, means it depending on that, such environment is used which does not affect or make any changes in that metal powders. Depending on that, we can use oxidizing, reducing, or neutral atmosphere to conduct this sintering process. Generally we are using reducing atmosphere. In this, and the generally used source for this sintering, the atmospheres used are dry hydrogen atmosphere or dissociated ammonia atmosphere or exothermic atmosphere having low or medium carbon potential, and sometimes we can use endothermic atmosphere having hydrogen gas. Okay, so in this way this sintering is completed. Component of obtained after this sintering is termed as sintered component. Okay, now this is the graph which will show you the effects on the properties of that compact after the sintering, and it will get converted into sintered compact. Okay, what will be the effects on that component? Due to the sintering, its porosity will decrease, sharply decrease. Okay, due to the heating, and its density, strength, and hardness will increase rapidly or improve with significant amount. Why this is happening? Because diffusion, densification of the metal particles is occurring, and due to that, okay, within this recrystallization and grain growth is also taking place. Due to that, three stages: diffusion, densification, recrystallization, and grain growth. Density is increases, and as well as strength and hardness will increase as sintering temperature is increasing. The next parameters, okay, sintering temperature and compacting pressure. Okay, low compacting pressure, medium compacting pressure, and high compacting pressure. Okay, this is the graph which shows the effect of compacting pressure and sintering temperature on the density of that component. Okay, to obtain theoretical density values, we have to use the medium compacting pressure or low compacting pressure with higher sintering temperature values to get the theoretical density values, and we have to avoid high compacting pressures. Okay, high compacting pressure should be avoided. Okay, so this graph will show you most suitable is medium or low medium compacting pressure with high sintering temperature. Along due to that, we will get the most desired density in that component or theoretical density values. Approximate theoretical density values can be obtained. Exact theoretical density values cannot be obtained. Okay, after the sintering, the next stage is signing. It is also next stage is coining or sizing. Okay, as we have discussed in the sintering stage, what happens in the sintering stage? Due to diffusion of one metal powder particles on the other metal powder particles, densification or some changes in the sizes of that component are taking place. Now these changes means the sintered component will have different shape and size from other than the our need or requirement of final product. There may be some distortions or some size changes due to the sintering process. Now this size rectification is done by placing that component in one master die with and applying pressure. This process is termed as coining or sizing. Okay, there are changes in the shape and sizes of that component due to the sintering process, and that are fixed with the help of one master die and upper punch and lower punch, or upper plunger and lower plunger. With the help of this master die, with application of pressure, we are fixing it. This process is termed as sizing or coining process. Sometimes we can go for machining operation also, means just a removal of that material will be there to get desired shape and size. Okay, and during this step only we can perform some extra operations like impregnation or infiltration. Okay, suppose we want to feel the pores present on the surface of that metal with the help of oil, with the help of oil, then that process will be termed as impregnation. Okay, filling the pores on the surface with the help of oil, it is termed as impregnation. And filling the pores on the surface with the help of molten metal, that operation will be termed as infiltration. Okay, depending on our requirement or depending on our applications, we can do impregnation or infiltration operation. But before doing whichever sizing coining is required, that you have to do before starting of this impregnation or infiltration method. After doing this impregnation or infiltration method, we cannot go for sizing or machining operations. Okay, that cannot be done. Before that, you have to do the whichever size rectification is there, that you have to do previously, and then you have to go for impregnation or infiltration operation. Then we will move towards the next stage. Okay, then we will move towards the next stage. That is the final stage. This is the fifth stage, sizing, coining or machining. And inside this, we are going to perform any extra operation like impregnation, that is filling the pores with oil, or infiltration, filling the pores with molten metal. And after this fifth stage, the final or sixth stage is the testing and inspection. Okay, now with the final component obtained, that we have to test it before the practical using it practically for various properties. Okay, first it is tested and inspected for its say size, shape, and whether any kind of defect is present in that component. Okay, that inspection or checking is done by using different non-destructive testing methods or destructive testing methods, or different measuring techniques. We can do this inspection. Then its various tests are conducted on that final product or component, like what is tensile strength, compressive strength, hardness testing, then porosity testing, density, and its composition is checked, its microstructure is checked. So these kind of various testing and in different inspection methods, different destructive testing methods or non-destructive testing methods are done, and that component is tested and inspected whether it is having correct shape and size and it is defect free with desired properties in it. And if it satisfies all these conditions, then that component is finalized for practical use. So these are the 6 stages. This is the final stage, testing and inspection. In this way, these 6 stages we have used. Okay, 6 stages we have used in this manufacturing a component using powder metallurgy technique. Okay, powder production, different methods we have discussed, then blending or mixing, compacting or pressing, then sintering, sizing or machining, testing and inspection. Okay, this part we have completed. Then we will move towards next point. If you have any difficulty, put that in the chat box. Okay, here I have summarized some common factors that will affect the properties of final component. The first factor will be size, shape, distribution, porosity, density, chemical composition, surface characteristics. Means whichever powder particle you have selected, its properties. That will be the first factor that will affect the properties of the final component. Okay, powder particles properties. Then the whichever compacting pressure, types or lubricants we are using in the blending or mixing stage. Okay, compacting pressure, compacting type, and any other elements, lubricants we have added, that will affect the properties. then sintering type, sintering temperature, sintering time, and atmosphere used in the sintering. These parameters will affect the properties, final properties of the powder metallurgy component. Okay. So after this, now we will move towards the advantages of powder metallurgy technique. Some advantages are there, advantages, disadvantages, and a few applications that we will discuss in this session only. Okay, if you have any difficulty, please put that in the chat box. Okay. Now we will start the discussion related to the advantages of powder metallurgy technique. Now these are the advantages. Lots of advantages are there. I have highlighted here. The first advantage is we can manufacture metal plus metal component. Okay, metal plus metal component with any desired composition without referring to the equilibrium diagram or phase diagram. Okay, as we have discussed earlier in for the steels or a non-ferrous alloys, whenever we are manufacturing any component or alloy, we have to refer its equilibrium diagram. But here the case is different. Metal plus metal components with any composition can be manufactured without referring to its equilibrium diagram. This is first advantage. And second advantage, we can manufacture a component with having metal and non-metal composition. Okay, metal plus non-metal components with desired composition can be manufactured, and this we can do without referring their equilibrium diagrams or phase diagrams. Then the third advantage or next advantage of this powder metallurgy technique is we can obtain controlled porosity in the component. Controlled porosity can be obtained, and as we can control the porosity, depending on our need, we can increase the some fatigue strength or fatigue life of that component by increasing their porosity. Okay, if this controlled porosity is up to 20 to 30%, we can increase the fatigue life of that component. The next advantage of this powder metallurgy technique is with the help of this powder metallurgy technique, we can manufacture a component which will give you the properties very much similar to the parent metals. Okay, in alloys, what we have seen, some properties of parent elements will get lost, but here not the case like that. It is possible to get properties of parent metals in the final component also. Then with the help of this powder metallurgy technique only, we can manufacture the some refractory metals like tungsten, molybdenum, titanium, thorium. These refractory metals have very high melting point. Hence, the processing or giving shape, desired shape to these metals is very difficult. Hence, we can use this powder metallurgy technique to give them desired shape and size. Like suppose tungsten wires can be formed, and that wires can be used in the lamp filaments. Okay, and then the components, suppose two metals are there which are insoluble in each other in liquid state, then it is not possible to manufacture their component with help of that two metals, but it is possible in powder metallurgy. We can use their powder particles to get the uniform distribution of one metal into another metal, and we can manufacture the desired component also. And then some very hard materials are there, that is carbide cutting tools, cemented carbide cutting tools, or diamond impregnated tools. And this manufacturing can only be done with the help of powder metallurgy technique only. Then manufacturing the component, this is the next advantage, manufacturing component having metal non-metal layers, layer by layer, metal layer, non-metal layer, metal layer, non-metal layer. Like these layer by layer arrangement of metal and non-metal is only possible by this powder metallurgy technique. This is the advantage. And the next advantage is there is a very little chance, whichever purity is there, high purity is maintained in this powder metallurgy technique, means chances of contaminations or impurities getting catched in the final component are very less in this powder metallurgy technique. Okay. And then next advantage, whichever powder metallurgy components are manufactured, we can perform the other heat operations, like suppose welding, brazing, or machining, or to change their properties, heat treatment processes, or some impregnation. Okay, impregnation operation already I have discussed, means filling the surface pores with oil. That can be done, means after manufacturing also we can do other operations also, other operations or some heat treatment processes can easily done on the powder metallurgy components. Then close dimensional accuracy can be obtained. Okay, means desired shape and size components can be manufactured. Then very small machining or very less machining is required, and hence whichever scrap is produced, it is very minimum in this powder metallurgy process. And then if suppose simple shaped component is there, then we can do the rapid manufacturing, okay, or mass scale production can be done if it is having a simple shape with the help of this powder metallurgy technique. Then high skilled worker is not required for the plant operation or its maintenance. Then other important advantage of this powder metallurgy technique is the composite materials. Okay, different composite materials like particulate composites or a simple that fiber reinforced composite materials can be manufactured by this powder metallurgy technique only. Then in this powder metallurgy technique, we are manufacturing different metal powders. Suppose aluminum powder, magnesium powder we are manufacturing, and that metal powder can be used for different application. You can manufacture their component also, but that powder is also helpful in different operations. Like suppose aluminum powder we have manufactured, we can use it, that aluminum powder, for painting or for doing the welding operation, or in RCC construction also we can use that aluminum powder. Okay, then that aluminum or magnesium powder we can use them in the explosives also. Okay, in explosive or in different pyrotechnic applications we can use these powders. So these are different advantages of the powder metallurgy process or techniques. Then there are some disadvantages also that we will discuss. Okay, now as the last advantage I have discussed that different fine metal powders can be manufactured, like aluminum, magnesium, then titanium. Okay, that different magnesium, aluminum I have discussed. Titanium can also be manufactured, but these metal powders may get exploded if they are not protected. If they come in contact with air, explosion may occur. Hence proper care should be taken, proper safety precautions should be taken or during their preservations. Or some metal powders may get come in contact with oxygen and they may form their respective oxides. In this way loss of metal powder may take place. Hence, to avoid this deterioration or loss due to the some explosions or oxidation process, proper cares is required. Okay, then this powder metallurgy technique is not suitable for manufacturing small number of components. Okay, it is economical when we are doing the mass production. If small quantity of component is manufactured, then initial investment in the tooling and equipment it becomes very uneconomical. Then large sized components, okay, large sized components cannot be manufactured with the help of this powder metallurgy technique. Then complex shaped components or parts also cannot be manufactured with the help of this powder metallurgy technique. Then whichever powder metallurgy components are manufactured, they will give you very poor corrosion resistance. Why corrosion resistance is poor? Due to presence of porosity. Due to presence of porosity, if that internal area means it is very susceptible or sensitive to the corrosive environment. Corrosion may occur easily. Okay, and then the theoretical density values cannot be obtained with the help of this powder metallurgy technique. Little bit less density will be obtained. Then due to the presence of porosity, the characteristics or properties like ductility, tensile strength, or hardness or toughness, it is very poor if you compare the powder metallurgy component to the conventionally manufactured components. Suppose casted products or forged components are there, then they will give you better tensile strength or hardness. And whichever surface finish is there, it is little bit poor if you compare it with the conventional methods. So these are disadvantages of a powder metallurgy technique. If you have any difficulty, please let me know. I will try to resolve it. So in this way, we have finished the advantages of powder metallurgy technique, then disadvantages of powder metallurgy technique. Now we will move towards the application part. Now this there are number of applications of powder metallurgy technique, or this powder metallurgy manufactured components are widely used in different sections, like in automotive applications, in defense application, and then in atomic energy applications, high temperature or aerospace applications. Okay, different applications are there. One by one we will discuss. Okay, in automobile field or in automotive applications, okay, from powder metallurgy we manufacture different components. Like suppose we have manufactured self lubricating bearing. Okay, self lubricating bearing is manufactured. That self lubricating bearing or porous bearing, it is used in the different starters, wipers of the vehicles, sliding doors present in the vehicle, then dynamos, clutches and brakes of cars, buses, trucks, or tractors. Okay, in these clutches or brakes of the vehicles, porous bearing is used. It is also known as self-lubricating bearing. Then sintered gears. These sintered gears are manufactured by powder metallurgy technique, and these sintered gears are used in cars and trucks. Okay, then sintered friction material is manufactured with the help of powder metallurgy technique only, and that are used in manufacturing of brakes, and that brakes are used in different vehicles like cars, buses, trucks, or different aircrafts also. Okay, then this in the automotive sector, different electrical contact materials, then crankshaft drive, piston rings, brake lining, connecting rods, all these can be manufactured with the help of this powder metallurgy technique only. Then in defense sector, the whichever metal powders we are manufactured, that can be used in rockets, missiles, or cartridge cases, in bullets, or military pyrotechnics like tracers or incendiaries. What is meaning of this incendiaries? Incendiaries means one type of bomb device. Okay, bomb device. In various applications of this defense field, we can use powder metallurgy technique. And then the atomic energy applications. Okay, now here different composite materials are there. Okay, different composite materials are there. Okay, now in atomic energy application, this powder metallurgy components can be used. Some composite materials manufactured by these powder metallurgy techniques can be used in various fuel elements and in control rod system. Then the dispersion strengthened materials which are manufactured by this powder metallurgy techniques can be used in atomic reactors, then high temperature gas turbines, then in computers or in magneto hydrodynamic generators. We can use these powder metallurgy components, that is like dispersion strengthened materials. And suppose beryllium zirconium metal powder is there, We can use this beryllium zirconium metal powder in control rod and radiation reactors. Then zirconium manufactured metal powder can be used as a cladding material. Cladding is very much similar to the coating, just protective coating is there. Then beryllium can be used as moderator in nuclear reactor. This beryllium powder and zirconium powder, it is manufactured in this powder metallurgy only. Then uranium oxide dispersion strengthened stainless steel. It is one composite material, and this is used as fuel element. Uranium oxides dispersion strengthened stainless steel. Then some other applications are there, like parts in the clocks, timing devices, or typewriters, or that adding machine, calculators, permanent magnets, or laminated bimetallic strips. All these can be manufactured by the powder metallurgy technique. Then the next, the high temperature applications and aerospace applications. Okay, the refractory metals and their carbides. Okay, refractory metals means tungsten, molybdenum, titanium, chromium, vanadium. These are refractory metals having very high melting point, and their respective carbides. They can be used in high temperature services, and these all are manufactured by powder metallurgy technique only. Then refractory metal carbides can be used for manufacturing of different cutting tools, different dyes or different rolls, and which can work at high temperature ranges. Then components made from this tungsten, molybdenum, then tantalum by this powder metallurgy technique can be used in electric light bulbs, that filament, then fluorescent tubes, radio valves, mercury arc rectifiers, then X-ray tubes. Okay, whichever filament is used in the electric light bulbs or X-ray tubes, that filament is manufactured from these elements like tungsten, molybdenum. All these refractory metals are there. And then in cathode, anode, then screen and control grids. This can be used in your television sets. Okay, that can be manufactured with the help of this powder metallurgy technique. Then in aerospace industries, the metal powders like beryllium, aluminium, magnesium, zirconium, these all metal powders are manufactured in this powder metallurgy technique, or this powder metallurgy is used as solid fuel in rockets and missiles. These metal powders are used as fuels in rockets and missiles, and all these metal powders are manufactured from these elements only. Then different parts in plasma jet engines, then ion engines are manufactured by powder metallurgy technique. Then different types of bronze bearings, filters, ferrite cores for transformers and inductor coils, then alnico-magnetic material. Okay, different kinds of materials are there, and these materials are used in space vehicles or satellites vehicles or satellites. All these are manufactured by powder metallurgy technique only. Okay, in this way, this powder metallurgy technique has a different or wide applications in automobile industry, in defense industry, in atomic energy industry, or in high temperature industries, or in aerospace industries, and some other applications we have discussed. Okay, so if any difficulty is there, please mention that in the chat box. Okay, I will summarize this session and I will stop here now. I will summarize it. In today's session, what we have discussed, I will summarize it. In today's session, we have started with the Okay, in today's session we have started with the concept of powder metallurgy. It is branch which deals with the manufacturing of metal and non-metal powder. And using this produced or manufactured powders, how to manufacture the component, following different stages that we have discussed. These steps involved in the manufacturing of the component in powder metallurgy technique, like powder production, blending or mixing, compacting, then sintering, sizing or machining, and testing and inspection. We have discussed this one by one. Different powder production techniques like mechanical processes, physical processes, chemical processes, and electrochemical processes, along with their subtypes, we have discussed in this today's session. And we have discussed how we are conducting mixing and blending, what is the difference between mixing and blending, and which extra ingredients we are adding, like lubricants, binders, and deflocculants, to get desired properties. How then which blending and mixing devices we are using, then the compacting or pressing with three stages like filling, pressing, and ejection, and its two types like hot compacting and cold compacting. We have completed this. Then what are the effects of this compacting, then what is the effect of compacting pressure on density of compact, then how sintering is occurring at high temperature to give high strength and hardness component by three stages: diffusion, densification, and recrystallization with grain growth. And along with two types of sintering, solid phase sintering and liquid phase sintering. Effect of sintering temperature and compacting pressure on theoretical density, we have discussed it. Then we have discussed the effect of sintering temperature on various properties like density, strength, hardness, and porosity. Then the how the sizing, coining, or machining is done with the help of a master die. Then what is the how we are going to do impregnation and infiltration process. Then the testing and inspection, the final component is tested and inspected for its shape, size, and whether any kind of defect is present, and various properties like strength, hardness, density, microstructure is checked with different techniques, and that component is used. And then these are the factors affecting the final shape and size of the component. Okay. And then advantages of powder metallurgy technique, disadvantages of powder metallurgy technique, and applications in automobile field, defense field, then atomic sector, high temperature application industries, and aerospace applications. We have discussed this. If you are not having any doubt, I will stop this session here only. Thank you for attending this. If you please give your comment also on this session. Thank you very much.